بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، السلام عليكم ورحمة الله وبركاته. اليوم سنتناول مراجعة عامة على الوحدة الثالثة resultant of the two collinear forces or parallel collinear forces. We know that parallel forces like and unlike. Welcome my dear student in our math program for secondary 3. Today we are taking revision of the unit 3. Unit 3, its title, revision about parallel forces. We know that my dear student, parallel forces, we have like forces in the same direction R equals F1 plus F2, but unlike means F1 opposite F2, R equals F1 minus F2, and R with the biggest force in direction. R in magnitude equal F1 minus F2. In this case, R with the biggest force. My dear student, look at revision about parallel forces. Resultant of a parallel collinear forces. My dear student, look at, we have two like forces. F1 acts at A, F2 acts at point B. Are resultant of the two forces act at point C in same direction, the C vector of direction. In this case, resultant of the two like forces means parallel forces have same direction. In this case, the resultant is a force in same direction as two forces. Its magnitude equal to sum of magnitude of the two forces. R equals F1 plus F2. But its direction or its line of action divides the distance between the line of two forces in the inverse ratio to their magnitudes. What you mean? F1 multiply AC equals F2 multiply BC. R equal F1 plus F2. But F1 multiply AC equal F2 multiply BC. Or F1 over F2 equal BC over AC. This mean inverse ratio of their magnitude. F1 times AC equals F2 times BC. Look at the first example. Two parallel forces of magnitude 20 and F Newton act at 2 points A and B. Magnitude of their resultant is 35 Newton. Remember, my dear student, R 35 more than 20 force F1 act as the point C and AC. Its length CAC equal 15 centimeter. Length of AB equals what? Choose the correct answer. 15, 35, 45 or 20. Remember, think before choose the correct answer. We know that we have two forces 20 and F. Its resultant 35, which act at point C, belongs to AB line segment. We know that F1 plus F2 equals 20. Therefore, the F equals what? 15 Newton. And we know that, my dear student, F multiply BC equal 20 multiply 15, or 20 multiply AC equals 15 multiply BC. By using cross multiplication, too easy to find BC length. Resultant more than given force. Then the two forces in same direction. When resultant more than given force, then we deduce the two forces in same direction. Resultant between the two forces 35 equals F plus 20. The value of F equal 15 Newton. By using 20 times 15 equals 15 times BC. 15 the value of the force F. By using BC cross multiplication, 20 times 15 over 15 equal 20 centimeter. Then the length of BC is 20 centimeter, or the resultant 35 act at 20 centimeter from the point B. AB equals 15 plus 20 equal 35. Remember, in this case, the distance between, or the length AB, length between two forces F and 20 equal 35. Now we are translate to another example. A, B, C, D, H are 5 points on a straight line, where AB equals DH equal 20 centimeter, BC equal 30 centimeter, CD equal 6 centimeter. Three forces of magnitudes 15, 25, 35 Newton act at A, C, H in same direction and perpendicular to AH. Two forces of magnitude 20, 30 Newton act at point B and D in the opposite direction to that set of first forces. What is required? The resultant of these forces. Look at in the opposite figure. We have 5 points or 6 points A, B, C, D, A, B, C, O, D, H. We have three forces downward. 15 acts at A, 25 acts at C, 35 acts at H. Two forces opposite at B, 20 at D, 30. Look at the forces up, its sum 50, 30 plus 20. But the forces down, 15 plus 25 plus 35 equals 75. What you deduce? The resultant must be the biggest force. Resultant R must be biggest force, downward. What is the R? R equals sum of the down forces 35 plus 25 plus 15 minus 50. Remember, R resultant of the forces which act at X centimeter from the point A. We let or suppose the resultant of the forces R act at a point O as the distance X centimeter from A. Look at R, a distance X centimeter from A. R equals summation of the forces up minus summation of the forces down. Answer is 25. Moment about E equals what? Remember, we have forces rotate about A clockwise and forces rotate about A anti-clockwise. Which the forces rotate about A anti-clockwise? 25, 35, and 20 and 30 with clockwise, with negative sign. Moment about A equals what? Negative 20 times 20 plus 25 times 50 minus 30 times 110 plus 35 times 130. Then moment about A must be equal moment about of resultant about A, 25x. What you mean? We know that the moment of the forces about point equal moment of resultant at the same point. To calculate value of x, x is 2100 over 25 equal 84 centimeter. This example very important. Why? Because there is a theorem. Say the moment of the forces at any point equals the moment of the resultant at the same point. Now we are translate to another example. Two parallel forces, magnitude of their resultant is 350 Newton, and the magnitude of one of the two forces is 500 Newton, acting at a distance of 51 centimeter from result. Then the distance between the two forces is, choose the correct answer, 100, 170, 130, 150. Look at in the opposite figure. The point A, the point B, and the point C, distance between them 51 centimeter. The force which act at the point B 500, the point C 350, the point A which act at F. To calculate, remember, in this case, R equal F1 minus F2. By substitution, in this case, the value of F2 equals 150. Then, by using F1 times AC equals F2 times BC. F1 150 times AC, 500 times 51 BC. Then AC equals 170 centimeter. The value of AC. Remember, the value of AB equals 170 minus 71, minus 51. If the required to find AB length, we subtract 51 from 170. Now we are translate to another example. The opposite figure show light road AB. The parallel forces shown in the figure act on it. If the magnitude of the resultant 300 R Newton and it acts up the point on the road and is 4 meters from A, find F and K. Look at the force F, the force K, unknown. How to find? We have resultant of the forces, forces up, forces down. Maybe forces up equals 200, 300, forces down, F plus 100. And there is unknown K upward. Forces up equal forces down, and find the moment at any point. Look at, we know that 300 equals K plus 200 minus 100 minus F. Why? Because R is 300. R resultant of the forces with the biggest force. Then R resultant of the force equals the biggest force minus smallest force. In this equation, we find equation of two unknown F and K. F and K, the relation between them, K minus F equals 200. We need other equation. Why? Because we have two unknown, K and F. K minus F equals 200. We need other equation by using what? Excellent student. By using moment about any point. Moment about O equals 0, then the point negative F about B times 3 about point O. O, remember, my dear student, negative F times 3. Why? Because the direction of the force was clockwise. 200 times 6. K times 1. 100 times 4. The distance, remember, the distance between K and O, 1. Therefore, calculate the second equation, negative 3F, negative K equal negative 1,600 by using adding 1 and 2 or substitution method or omitting method. F equals 350 and K 550. Now we are translate to another one. A rod of length 100 centimeter and its weight W acting at its midpoint is suspended in horizontal position by means of two vertical strings at its end. Determine a point on the rod which weights of 5 W is suspended such that magnitude of the tension in one of the two strings equals twice its magnitude in the other string. Look at, my dear student, in the opposite figure, we have T tension at point B T double at A to T. We have two weights. We have two weights, W and 5W. Act at O, act at C. The first equation, forces up equal forces down, or forces up minus forces down equal 0. 2T plus T minus 5W minus W. W represent weight equal 0. 2. Find equation of T and W. T equals 2W. This equation number 1. We need moment at a point A equals 0, then 5 Wx minus 50W minus 10T equals 0. Therefore, divided each term by W, therefore x equals 30. Now we are translate to another one. In the opposite figure, F1 parallel F2 and act at A and B respectively. such that A belongs to BC straight line. BC line segment 24 centimeter, then AB equal what centimeter? 20 centimeter or 10 or 11 or 12. Look at, my dear student, we have two forces and R equals 10. F1 equals 30 minus 10 equals what? Equals 20. Why? Because R with the biggest force. R with the biggest force equals 10, F2 equals 30, then R equal F2 minus F1 equals 20. F1 equal 20 by using 30 times moment 24 equal 20 times 24 plus AB. Therefore, to calculate AB equals 36 minus 24 equals 12. My dear student, look at the important example. F1 and F2 are two parallel forces. The distance between the line action of resultant and the first force is 9 centimeter, and from the second 12 centimeter. Remember, we have two parallel forces, F1 and F2. The distance between the action of resultant R and the first force F1 is 9 centimeter, and from the second 12 centimeter. If the magnitude of their resultant is 14 Newton, find F1 and F2 if the two forces act in the opposite direction. Look at, my dear son. In the opposite figure, F1, F2 in opposite direction. R equal 14. We have two unknown, F1 and F2. We need two equations. The first equation, F2 equal F1 plus 14, or 14 equals F1 minus F2. And we need other equation by using the moment. Then, my dear student, 14 equals F1 minus F2. Why? Because 14 is the resultant. Why 14 not equal F2 minus F1? Someone asked. We know that the resultant with the biggest force. 14 with the biggest force with F1. Then we start from F1 minus F2. Therefore, my dear student, we need another equation. We know F1 times AC equals F2 times BC. When we have two forces are parallel, opposite direction, as F1 and F2, we multiply F1 times AC equals F2 times BC. Therefore, F1 times 9 equals F2 times the distance between B and C is 12. We have two equations, F1 minus F2 equal 14 and 9F1 equal 12F2. We divided 9 and 12 each term by 3. Then 3F1 equal 4F2, or to find the relation between F1 and F2, F1 over F2 equal 4 over 3, or F1 equal 4 over 3 F2 by substitution in equation 1. Then we know that by using ratio 4k minus 3k equal 14, then k equal 14. F1 4k, 4 times 14, F2 3 times 14 equal 42. Then F1 56, and F2 42. If we subtract F1 minus F2, the resultant are 14. Remember, maybe someone solve by using substitution method. This right. By omitting method, also right solution. The rod in equilibrium, look at, we have two forces up and three forces down. Two forces are same F and F, which act at B and D, and we have three forces down 8, 10, and 6. In equilibrium, the forces up equal forces down. 2F equals sum of forces. 8 plus 6 plus 10. What is the value of X? Choose the correct answer. 2, 3, 5, 4. My dear student, in the opposite figure, we have forces which act at down at A 10, at A 8, at H 6, and our resultant R 10. We have two forces F at B and at D at a distance x centimeter. What is the value of X? Is 2 or 3 or 5 or 4? We know that sum of the forces up equals sum of the forces down. 2F equals 24. The value of F equals 12. By using the moment at point B equals 0. We have point at the point B, the moment negative 8 times 4 plus 10 times 2 minus 12 times x plus 2 plus 6 times 6 multiply x plus 8. Remember, my dear student, this moment about B, 6 plus 2 plus x. 6, this is the force, times x plus 8. The distance between H and B, 6 plus 2 plus x, 8 plus x, equals 0. Therefore, find the value of x. In this case, x equals 2. Then the correct answer is 2. My dear student, by the end of the lesson, we know that parallel forces, important lesson, we have resultant of the two coplanar parallel forces are equals F1 plus F2 in same direction, but are equals F1 minus F2 in the opposite direction, and are with the biggest force in direction. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.